Okay, so when you talk about the basic derivatives as a key concept, now since beginning of the first class itself, I have pointed out that okay, what does actually derivative represent? Now, derivative is actually a slope function, or you can say it's a gradient function for the original curve. Now, what does it mean to us? So now let us say if I have to draw a tangent at any given point, let's say I'm drawing a tangent from here to the curve. Now, if I wanted to find out what is the equation of this tangent, okay, that I've drawn at, let's say, x equals to whatever this point is, our derivative function can help us. Now, since we know that the dy by dx represents the slope formula, slope or um, gradient for tangent at a given curve, at a given point on the curve. So now let's say I'm just taking a simple example and illustrating how can we find out equation of, let's say, tangent of the function. Let's say f of x is 1 over x, and I want to find out equation of tangent when x is, let's say, 2. So if I draw tangent at x equals to 2, what is its approximate like an equation? So let's say if I draw tangent at x equals to 2, this is how the tangent is probably going to look like. Now, our first step is to find out the x and y coordinate at which you're drawing the tangent. So now let's say here my x coordinate is 2, but I don't know the y coordinate. So what you're going to do is first, using the original equation, find out the y coordinate. Because as you know, to find out equation of a line, you simply require slope and a point. Now I have x coordinate of the point, but what about the y coordinate of the point? So when I plug x as 2 here, I get y equals to 1 upon 2. So my this coordinate that at which you're drawing the tangent is actually 2 comma half. Now that's our first step. Number 2 is when you look at the second part, which I need is the slope of the particular line. Now for that, we need to do the derivative, because as we know that the derivative represents the slope. So our first step is to find out the derivative of this function. So if y is 1 over x, I'm just going to modify a little bit x to the power minus 1. And then we're going to do dy by dx, which is going to be negative 1, x to the power negative 2. So the formula for x to the power n, as we know that, it is n x to the power n minus 1. So here my derivative formula or slope formula is negative 1 over x squared. So now we got the slope formula. I'm now going to plug x as 2 here to get the exact slope of this line. So if I plug x as 2 here, so slope of this tangent is negative 1 over 4. So the m value for this tangent, you can see, is negative 1 over 4 at x equals to 2, which you've drawn. So the slope of the tangent is always given by the derivative. What you just need to do is plug in at which x coordinate you want to find out the slope. Now let us take a couple of more examples. Now, for example, here, if I had to find out the slope at x equals to minus 4, then I'll plug just x coordinate as minus 4 here. So what derivative that you got, the formula that you got, is actually the slope formula for that curve at any given point. You just need to plug in the x value. Now coming back to the final equation, how do I get the equation of this line? So there are two ways you can use. Either you can use y equals to mx plus c, or you can use y minus y1 equals to mx minus x1. Any of the two formulas should be fine to get the exact equation of the line. Let us say I go on the first one. So y equals to, since my slope is negative 1/4 x, negative 1/4 x, it is going to be plus c. Our next task is to find the c value. And how do I find c value? By taking this x coordinate. So when I plug x coordinate as 2, my y coordinate is half. So half equals to negative 1/4 times 2 plus c. This 2 and 2 get cancelled, and you get c as half plus half, which is 1. So the c that you get here is y equals to negative half x plus 1 as a result of like c being 1. Our equation is negative half x plus 1. So the line, now equation of this line, if you see that, if I draw a tangent, if I draw this line, which is y equals to, it's not negative half, pardon here, this is actually negative 1/4 because my x coordinate is, I mean, the slope is negative 1/4. So that's my equation. So I'll just now draw this equation as y equals to negative 1/4 x plus 1. You can see that the line that now I have got is actually the tangent to this particular curve at x equals to 2. Cutting y-axis at 1, and that's how you find out the equation of the tangent at this curve. Now, our next step is actually to see, understand what is normal. Now, normal is actually a perpendicular line to the tangent. When you look at the normal here, the normal will be something like this. So normal actually is always at right angle to the surface of the curve. So it's like if your tangent is this, the normal is this, which makes a right angle to the curve, as well as with the tangent. So how do we tackle the equation of tangent now? Because the equation of normal now. Tangent also passes through 2 comma half. Normal also passes through 2 comma half. So we have the point, but we don't have the slope. And at that time, you're going to use this concept of slope of being two lines. If they're perpendicular, the slopes multiply to negative 1, or you can say the slopes are negative reciprocal of each other. So if m1, so m2 will be negative reciprocal of 1/4. So negative reciprocal of 1/4 is 4. So the slope of this line, which is normal line, will be, slope is already 4. Now, what's our next step? Is to find out the equation of this normal. So let's see what is the equation of this normal. So y equals to 4x plus c. Now, plug x as 2 and y as half. So half equals to 4 times 2 plus c. So c will be half minus 8, which is, let's say, negative 15 upon 2, which is negative 7.5. So my equation for normal that we finally get is y equals to 4x minus 7.5. And let's see now if actually it is giving me the correct answer. I mean, let's try to see if this normal that I'm drawing is coming close to the normal to the curve actually. Y equals to, let's say, 4x minus 7.5. So you can see actually this normal, I mean, obviously what I had drawn earlier was just an approximation, but now the actual normal that you can see is this line, which is actually perpendicular to the tangent, and it passes through the same point. So that's how you find out equation of tangent and normal to a basic curve. So one of the very interesting question for close to 5 marks is now just the continuation of this, where they ask us to find out. Now, obviously, you can see the tangent never meets the curve again. So what the tangent I've drawn, it's just never crossing the curve again. But what is happening is, if you look at the normal, this normal that I've drawn is meeting the curve again. So that it's meeting at this point. And what they will say is that just use the equation that you derived to find out where does this normal meets the original curve again. Where does this normal meets the original curve again? So now the logic here is that, okay, if I look at the simple part of this function is, okay, so let's say I have y equals to 4x minus 7.5. That's one equation here. And the other equation is y equals to 1 upon x. So what I can do is, if I look at the logic of simultaneous equation, one of the intersection point is this, other point is this. So I will just solve this simultaneously and try to get what equation I'm looking forward to. So what we'll do is, if I have got the equation of tangent, I'm just going to equate these two. So 4x minus 7.5 equals to 1 over x. Then you cross multiply, it will become 4x squared minus 7.5x minus 1 equals to 0. So you actually get a quadratic equation. And if you solve this quadratic equation, you're going to get the value of x at which these two curves intersect, or the normal intersect the curve. So now when you solve this, you'll notice that your x coordinate is 2 and x coordinate is negative 1 over 8. So you can clearly see that the other point where the curves are meeting, these two are meeting, is x coordinate is negative 1 upon 8, which is negative 0.125. And to get the y coordinate, you get either plug x as, plug x as negative 1 upon 8 here. So you'll get y equals to negative 1 upon 8. That reciprocal of this will become negative 8. So the coordinate is actually negative 1 upon 8 comma negative 8. So that's how you find out where does tangent or normal meets the curve again. So you just need to find out the equation of that particular curve, whether it's tangent or normal, and then you find out the intersection using the normal simultaneous equation logic. So in this example, what we'll be basically working on is once again to find out the equation of tangent. Okay, so this is the curve that has been given. So y is 3x cubed minus 2x squared plus 2x, and show that the equation of tangent where x is 1 is this. Once again, the first step is to find out the y coordinate. Make sure you have the y coordinate. So when I have x is 1, y is, let's say, going to be 3 minus 2 plus 2, which is 3. So y coordinate is 3. Now, our next step is to find out the slope. So once again, we do the derivative. So dy by dx is going to be 9x squared minus 4x plus 2. And now here you plug x as a 1. So you get 9 minus 4 plus 2, which is 9 negative 2, which is 7. So the slope of the tangent is 7, and it passes through 1 comma 3, and you have to find out the equation now. So y equals to mx plus c. M is nothing but 7, x plus c here. Plug x as 1 and y is 3. So 3 equals to 7 plus c. So c is negative 4. So you can clearly see that our equation that we get is y equals to 7x minus 4. So that's how the first part gets done. Next part is find out the exact coordinate. Where does this tangent meets the curve again? So again, here we have to just like equate these two functions like simultaneously. So 3x cubed minus 2x squared plus 7x plus 2x equals to 7x minus 4. So you're going to bring everything one side. So it'll become 3x cubed minus 2x squared minus 5x plus 4 equals to 0. And then we're going to use technology or calculator to find out the value of x. So the value of x that you'll get is going to be, obviously after solving this equation, cubic equation, you'll get either x is 1 or x is negative 4 by 3 on your calculator. Or if you want to do with the long division polynomial, what you can do is, because you already know that x equals to 1 has to be one of the answer, it means that x minus 1 has to be the root of this polynomial. So if I do long division, you can see that the quotient will be 3x squared plus x minus 4. And if I factor that out, you'll get x is 1 and x is minus 4 by 3 again. So already x equals to 1 is 1 point. So the second coordinate that you get is negative 4 over 3. Now, once you got the x coordinate, plug this x coordinate here to get the y value, exact y value of the function. So now, once again, we might get the questions in the categories such as, let's say there is a function f of x is 4x squared minus 6x. The questions can be pretty straightforward. First can be like, okay, find out f of, let's say 1. Now f of 1 is, let's say 4 minus 6, that is negative 2. Now they can ask us, find out the equation of tangent when x is 1. So let's do that question. Find equation when equation of tangent and let's say normal, or for the matter now, let's do the only normal equation of normal when x equals to 1. So when I plug x equals to 1, I already got the y coordinate as -2. So the coordinate at which I'm drawing the tangent it is basically 1 comma -2. And next up is I have to find out its equation for the normal. So now you do dy by dx, which is going to be 8x minus 6. Now plug x coordinate as 1 here. So dy by dx will be 8 minus 6, which is 2. So the slope that you get is 2. Now you will find out the slope of normal. So slope of normal is going to be -half. And so equation of tangent will be y equals to -half x plus c. And plug x coordinate is 1 and -2. So, I mean, y coordinate is -2. So -half plus c. So that gives us c as -3/2. If you bring -half here, it will be -2 plus half, and which becomes -3/2. So equation of normal that we have is -half x minus 3/2. Now, considering the fact that obviously the other question can be here is find out where this normal meets the curve again. We follow the standard procedure that we did for last example. But now there can be a couple of more questions which can be linked up here. Number one is basically they might ask us to find out like equation of any horizontal tangent. Now, what does horizontal tangent mean to us? Now, when you talk about horizontal tangent, its slope is going to be 0. So if there is a tangent that is horizontal or flat, its slope is going to be 0. Of course, I can't draw tangent here, which is flat, or here is flat. So at the turning point, generally the turning points is the point where you draw you will have the horizontal tangents. So horizontal tangent, what is so special about them is that the slope is 0. That's how we use them. That's how we find them, by using this concept, slope being 0. And if I use because it's a quadratic equation, so we could have found out the vortex. But now this gives us a way to find out the coordinate of vortex again using calculus. So what we do is to find out the coordinates where the tangent is horizontal, we just equate dy by dx to 0 because slope is 0. Now, as a result of that, what we get is 4x squared minus 6x, derivative is 8x minus 6, equate to 0. So you get x is 6 upon 8, that is 3 upon 4. So x coordinate at this point that you'll notice is nothing but 3 upon 4. So we used to do minus b over 2a. You will still get the same answer if you do this method. So you do the derivative, equate to 0, you get the x coordinate of vertex. This is a shortcut, like you can take that way. Now, what we take is our objective is to find an equation of horizontal tangent. So what you're going to do is plug this x coordinate 3 over 4 out here to get the y coordinate. So if I do that, it will be y equals to 4 times 3 by 4, the whole square, minus 6 times 3 by 4. And if you simplify this, let's say 4 times 9 by 16 minus, this becomes, let's say, minus 9 by 2. If you open up the bracket, this becomes 4 4sa. So it's 9 by 4 minus 9 by 2. If you multiply this by 2, it'll be 9 minus 18, which is, once again, it's minus 9 over 4. So this coordinate that you get is going to be minus 9 over 4. That's your y coordinate. So because horizontal line will be where this crosses the y-axis, like something like this. So this point will cross will be minus 9 over 4. So equation of this will be negative 9 over 4. Now, if I draw that here, you can also see that that will be also tangent. If I do y equals to negative 9 over 4, you can see that it is nothing but the horizontal tangent that we were really looking forward to. So you can see, if I clear out the rest of the things, you can see it more clearly that this is the horizontal tangent. And now some question further can be extended, that find out where this normal and where this horizontal tangent meet. So obviously you're going to equate these two things and you solve for x. So these can be the multiple types of questions that can be assessed in your exams. So just be mindful of doing such questions very carefully, which will be on tangents and normals.